boys and girls, back for another edition of Burbank High Chemistry Labs. This is one of my favorite labs. And what we're gonna do is we're gonna do this single replacement reaction. Remember that from first semester. Now, if you remember one of the labs we did this reaction. We took a piece of magnesium, poured this is hydrochloric acid, right? Poured hydrochloric acid over it, and then boiled off the excess water and recovered the MgCl2. That was the white powder. We did that as a stoichiometry lab. This time, we're going to do the reaction, right? I'm going to take a piece of magnesium, react it with hydrochloric acid that's aqueous in water, right? Dissolved in water. And we're going to collect the hydrogen gas. So this is the guy we're going to collect. We're going to throw this guy out, okay? Now the acid's going to be excess, so our magnesium strip will be our limiting reactant. Okay, you'll see the magnesium will get all dissolved. So, and we're going to use, the goal of this lab is to show you how stoichiometry and the Pivnert equation, PV equals nRT, also poetically known as Pervert equation, how they can work together, right? So how you can do stoichiometry with Pervert or the Pivnert equation, right? And we'll do those calculations in class, okay? But what we're gonna do in the lab right now is we're gonna, we'll throw this out, right? And we're gonna collect the hydrogen. Now, how do you collect hydrogen gas? You're gonna use an this is a gas collection tube. It's also known as an eudiometer, okay? And so we're gonna show you how to do it, okay? So, the first step is to set up first step. I got to measure the length of my magnesium. So I'm going to measure the length of the magnesium. Okay. That's step number one, using a ruler, just like we've done before, right? We're going to use centimeters and we're going to estimate to the 100th of a centimeter. All right. So now we're using a smaller piece of magnesium. It's kind of hard to see from where you're at, but I'll do it. Okay, start at 1 there. Oh. Yeah, it's 1.95, just shy of 2. So I'm going to say 1.95 is the centimeters for that guy. So 1.95 centimeters. Yeah. Okay. All right. And then last year my TA measured out a meter's length of this magnesium. So a meter of this magnesium is 1.848 grams. So 1.848 grams per meter. All right. So just to show you guys real quick, right? Okay. So number one, I measured it, it's 1.95 centimeters. And number two, last year my TA measured out a meter's length, so it's 1.848 grams per meter, and that will be in our calculation section. We'll use that later. Okay, and then if you look at this picture right here, okay, we're going to attach the piece of magnesium to a piece of tape to a rubber stopper that has holes in it. Okay, so let me show you that. So magnesium strip that I just measured, the rubber stopper is in the eudiometer. We got our piece of tape right here. Okay, put the piece of tape on there, and then the trick is to put just the end of the magnesium on the tape. Get it stuck on there. Like, whoops, that's a little bit too much. And like that. There we go. All right, so it looks like that. Okay, And then we're going to set that off to the side. And the tape sticks a little bit, we'll take care of that. Now we got to fill up. What's the next step? It says get approximately 10 milliliters of 6.0 m hydrochloric acid. All right, so here's our hydrochloric acid, that's AQ. And the 6M is a measure of how concentrated it is, which you will learn shortly after this unit, actually, when we talk about solutions. All right, but here's the HCl. Oh, I need a funnel. All right, so I'm going to pour the 10 milliliters of acid. Remember, since the acid is the excess reactant, we don't have to be, 10 milliliters is about there. So we're just gonna pour that in.
It's a good thing you're wearing your goggles.
Yes. Getting this in my eye would send me to the urgent care. Okay, so there's about 10 milliliters right there. As long as it's 10 or a little bit more is fine. You know you have enough to completely react the magnesium. All right, so put that away. All right, so we got our acid in here. Now we got I forgot, we need a squirt bottle.
Oh.
And some distilled water.
Okay, yeah.
All right, so we got our distilled water. The acid is right here. We're gonna pour the water in, okay, until it overflows, because we want to get rid of all the air in here. We don't want any gas in there except the hydrogen that's gonna be produced. So pour this in, right? It's overflowing, that's fine. Right, okay, see how it's overflowing? That's good. And see how that little bubble up, that little dome of water up there? That means there's no air in there, right? So now I'm gonna take my thing here, I'm gonna stick it in, okay? Just like that. Push it down. Okay, and I don't see any air. I'm looking all through here. I don't see any air bubbles, okay? So that's good. All right, now, the acid is down here. Water is about half as heavy as the acid. So the acid is still down here, it's not gonna float up. So how am I gonna get the acid to react with the magnesium, right? Because that's what we want. I'm going to put my fingers over this tightly so no air gets in, and I'm gonna turn it over. You getting this? Yeah, okay. And I'm gonna put it in this beaker of water here. Now I can remove my finger. Now, if you zoom in, Mr. Iwan, you can see the acid sinking down, right? Right. You can, if you look carefully, you can see the acid sinking down into the water, and it's going to start touching the magnesium down at the bottom there. Okay. Let's see if I can use this thing. If it works. Okay. All right, we can lean that up against there. That's good. But you can see the acid, if you know, sinking down. It's kind of cool. It's almost like a lava lamp. See how it comes down? It's right about here. Once it goes down, because remember the acid is actually heavier than the water, so when I turn it over, it started sinking. And you will see, once the acid starts touching the magnesium, you'll see bubbling, and that's the hydrogen gas escaping. Okay, because you can see it
Starting to bubble.
Starting to bubble. Now, we're gonna need some paper towels. Okay. So we're gonna let that, okay, we're just gonna let the reaction go. Now, why is water coming out, okay? Well, you can, now it's really starting to kick in. You see all these bubbles? That's hydrogen gas being produced. And so the hydrogen gas is rising because H2 is the lightest molecule. So it's gonna float up through the water, and you can see the hydrogen gas being collected right here. Now, remember, no two pieces of matter can occupy the same space, so since the hydrogen gas is building up in here, it's pushing the water out. And that's why we needed holes in the rubber stopper so the water can come out. So the hydrogen gas is pushing the water out. That's why the level of water is dropping. And it's pushing it out into the beaker, and you can see it's overflowing, right? I have to, but it's just water because the acid is being reacted, so I'm good. All right, so we're gonna, and you can see it's, oh, the magnesium broke off the tape, but it's still reacting, so that's good. It shouldn't be any problem. Actually, I hope it doesn't go below the 50 line or we're in trouble. Then I have to do it all over again. All right. Didn't you? I think I used too big of a piece.
Okay.
All right, so you can see all of this now is hydrogen gas being collected, and you can see the water level dropped all the way down here because the hydrogen gas was pushing the water out. So that's, and then the water entered the beaker here and started overflowing, so that's why we're wiping this. It's still overflowing. We're almost done. Oh, good. I don't see any more bubbling, and I do not see the hydrogen. I'm sorry, I don't see any pieces of magnesium in there, so we're good. Okay, so that's the reaction. So all of this right now is hydrogen gas. So I collected all this hydrogen gas, right? This guy right here. Okay, so here's what we're gonna do. Now, we need to collect the volume of the hydrogen gas. We need to collect the temperature and the pressure, right? So we can do the Pivnert equation because we're gonna solve for N, which is moles. Okay, so how, so the volume we're gonna read here, but how are we gonna get the pressure? I can't stick a pressure gauge in here. So what we're gonna do is we're gonna take, now watch this, okay? I'm gonna take the udiometer, I'm gonna put my finger over the hole so no air gets in there, and I'm gonna transfer it to this big guy right here. Okay, I can take my finger off. So no air got in, that's good. I didn't see any air. Now I'm gonna let it sit for a second. I'm gonna explain something. I'm gonna explain why we put it in here. Okay? Let me clean up a little bit. It's just water. Okay, all right. Now, here's the thing. If I measure the volume, okay, so you guys can't see from back there, but the numbers go down, okay? So if I look at the volume of the hydrogen gas right now, it's at, if I count down, it's at 27, is that 37? That's 37, okay. It's at about 37 point, let me make sure I'm reading this right. Yeah, the one, okay. Yeah, it's at about 37 point, I would say 6.5. Right about there. Now, why am I measuring the volume when this water line is equal to this, the water line in this big graduated cylinder? Okay, I'll explain in a minute, but let me take the reading when these two lines are equal. So it's 37.56. Okay? All right, so I'm gonna write that down. I'm gonna let it go. So the volume is 37.56. Okay, I'm gonna let that sit there for a second. Nothing's changing, there's no air getting in, the hydrogen gas is still in there. All right, so real quick, okay, so you can see this picture right here. We were supposed to take the volume of the hydrogen gas when the water line inside the udiometer equals the water line of that big graduated cylinder. And it was 37.56. Okay? Now, what is the H2O doing in there? Because anytime a gas bubbles up through liquid water, it takes some water molecules with it. So there's actually some water in gas phase also bouncing around in there with the hydrogen, and we'll deal with that when we deal with the calculations. Okay, because we really just want to look at the hydrogen gas. All right? But again, why did I measure these two lines? Because, and I'll show you right here, when this water line is the same as this water line, the pressure inside is equal to the air pressure outside. They equal each other, right? The air pressure outside is pushing on the water, which pushes it up the tube to the same level, right? It's just a trick that you can use. So that's how we're going to get the pressure. The pressure of the hydrogen gas is the pressure of this room, which pretty much is sea level, but we'll look on our phones and I'll report it to you later, what the air pressure is today. All right, so now we have the volume. The pressure of the hydrogen gas is the pressure of the room. So we got the pressure. Now we just need the temperature. So if I leave the hydrogen gas in there for a minute or so, which it's been, the energy has evened out. So the temperature of the hydrogen gas will be equal to the temperature of this water. So I'm just gonna really quickly take, excuse me, the temperature of the water. Okay? Give it a minute to settle. Okay, and the temperature of the water is, we're gonna estimate to the tenths place, right? Because each line on the thermometer is 1 degree. So that would be 19. Oh, okay, I'm sorry, not 19. That would be 17.2. Okay, so 17.2. That water's kind of cool. All right. Is it that guy again, that pesky guy?
Yeah, spam again.
Okay. All right, so I'm writing down 17.2 degrees Celsius. Okay, which is a cool temperature. It's a little below room temperature, but that water's kind of cool. All right, so I wrote the temperature of the water, which is the temperature of the hydrogen gas. Okay, and then we just need to take the temperature, the pressure of the room in centimeters of mercury, and I'll get that from my phone, right? Because whatever the pressure is in Burbank, that's the pressure in this room, and that's the pressure of the hydrogen gas. So that's the lab, right? We collected hydrogen gas, we got its temperature, pressure, volume, and we will use those values to calculate the moles of the hydrogen gas and compare it to what we're supposed to get, right? And see how well we do. Okay? Now, all I gotta do is just take this out of here and just let it go in the sink, all right? And we will set this down, and that's it, boys and girls, for this one.